The integrals of exponential functions is also quite straightforward. The integral of e to the x dx is equal to e to the x plus c. And if I have a function of u, then the integral of e to the u du is equal to e to the u plus c. So let's look at the integral of e to the 3x plus 1 dx. Let me make the substitution u equals 3x plus 1. Then du is 3 dx. So dx is du over 3. When I translate this, it becomes the integral of e to the u times du over 3. So it's 1/3 e to the u plus c. Now remember, I always have to transfer back. So it's 1/3 e to the 3x plus 1 plus c. This one's not quite so straightforward. Always let u equal your exponent of your exponential. Let u equal minus x squared. Du is minus 2x dx. So I have x dx in my integral. So x dx is du divided by minus 2. So when I rewrite this, plugging all of this in, I'm going to pull the 5 out. Becomes the integral. X dx is du divided by 2. And then this is e to the u. So this becomes 5 over 2, the integral of e to the u du. Or 5 halves e to the u plus c. And remember, we always have to transfer back. So this is 5 halves e to the minus x squared over 2 plus a constant. Now, this one is a little bit more complicated. Let's let e to the u equal e to the 1 over x. So that basically I'm saying let u equal 1 over x. Du is equal to minus 1 over x squared dx. So now I have x dx over x squared. Dx over x squared is minus du. So when I rewrite this, it becomes minus the integral of e to the u du, or minus e to the u plus c, minus e to the 1 over x plus c. Now, whenever you have trig functions, of course you want this to equal u. So let u equal cosine of x. Du is minus sine x dx. So I have sine x, I have dx. So when I solve for it, sine of x dx is minus du. So when I plug this back in, this becomes the integral of e to the u du times -1, so I'm going to put that negative out here. So this is minus e to the u plus c minus e, u is cosine of x. Now we can find areas bound by exponential functions. Definite integrals are the exact same. If I let u equal minus x, du is minus dx. So dx is minus du. U of 0 is 0. U of 1 is minus 1. So this becomes the integral from 0 to minus 1, and don't let that minus 1 bother you, of e to the u times du with a negative sign. So this is minus e to the u evaluated at 0 and 1. So it's minus e to the 1 minus e to the 0. Now, this is just e to the 0 minus e to the 1, or 1 minus e. Now, I made a mistake here, didn't I? Because I changed my limits of integration, I dropped a negative sign. So this should be a negative. Whoops. That should be a negative, and that should be a negative. So this should be e to the negative 1. So it's 1 minus 1 over e. If I were to try to find an approximate solution, this would be about 0.632.